It's my pleasure this morning to announce our first speaker, Jeff McVeigh from Intel Corporation. Jeff and I had the pleasure of working together when I was at Intel a few years ago, and he's an exceptional products guy, and he has more than 20 years at Intel delivering great visual computing experiences for Intel customers. So I'd like to welcome Jeff, and he's especially invited presentation by the Embedded Vision Alliance, Vision for All. Jeff?
Okay, well, thank you so much for coming. It's great to see everybody here, and as I saw in the packed keynote there, just some amazing technology that I'm sure we'll all see throughout this really great summit. My talk is a question mark, which is a little odd for a title for a presentation, and I'll give you the answer right now. It's yes, kind of, and I'll describe exactly what I mean by that. It's really about how do we democratize vision and computer vision technology so that it goes beyond the need, in particular, to have a PhD or decades of experience to deliver solutions that incorporate computer vision technology. And I'm going to try and motivate that with why it's happening, and then what it will mean for you, both as your business and potentially personally, as this change happens throughout the environment. And so hopefully that will be a good discussion for us to have here today. Before I get into those specifics, I want to just sort of set the stage of what's driving people to even care about vision. And we all are very familiar with the buzzword of IoT, and one of the common things in IoT is the internet connectivity, the ability to connect devices together and have those communicate. But another absolutely vital piece of IoT in my mind is the vision, or the eye, in many of these devices that span from smart cameras, that's an obvious one, to retail devices where you're able to see who's coming to your store, track them, understand their age demographics, to tailor content to them, to smart cities, autonomous vehicles, you name it. Pretty much all of these devices benefit from having visual perception embedded within them. Those devices themselves are then often connected to gateways that are somewhat in a local area network that can do storage of that information, more in-depth processing, and then also back-end data services that could be happening in a private on-premise cloud or a public cloud. And we see through numerous data points that this market is growing dramatically. Hundreds of millions of devices are being deployed with vision capabilities on them, millions and millions of gateways, and additional millions of back-end services. So the demand is there. The demand for these types of capabilities is available, and then how do we deploy these quickly, efficiently, and delivering it on a specific product need? I'll do my one commercial slide for Intel, so you won't see lots and lots of Intel slides here. But I do want to just highlight some of the capabilities from a hardware standpoint as well as software that Intel is bringing to bear across that spectrum that I just talked about. Many people are probably familiar with Intel in PC clients, but it spans much more than that. It spans from those smart cameras that it could include also robotics, drones, other autonomous devices, to the gateways, to the data center. And last year was sort of a watershed year for Intel in terms of a number of acquisitions that really rounded out our portfolio for computer vision. We built on an existing technology known as RealSense for stereoscopic depth cameras, purchased excellent company McVeigh, specialized in low power computer vision silicon, and really targeting that for some of the smart camera autonomous devices. Also purchased Altera for FPGA, for being really an innovation engine for us to utilize that for new algorithm development and to deploy that in a very power and performance efficient manner. And then also in the data center with Nirvana for artificial intelligence and deep learning capabilities for bringing both the training side and accelerating that, as well as bringing that to the edge. And really what we're delivering across this portfolio is end-to-end architecture with all the various pieces to bring those together, software compatibility, combining both classical computer vision with deep learning-based capabilities. We often also recognize that it's not just about the understanding of the video, but also pre-post processing, compression, storage, and transmission. And then also delivering a set of software development kits or SDKs to make developers' lives easier for them to access and to utilize those capabilities. So again, off my commercial for a second, but that's how Intel plays in this space. And what we also do is a number of ethnographic studies where we'll go and actually sit down and watch different developers, how they interact with the technology. What are their pain points? What are they trying to solve? So I'm going to give two ends of the spectrum. We actually talked to over 100 folks in the computer vision space to learn some trends, and I'll try and distill them down into two people, Gail and Patrick. And these are anonymized. They might look like you. It actually might have been you. Some of the people in this room were people that were part of these studies. But Gail is a person that works at a large multinational company. They specialize in differentiating with computer vision technology. So she's a specialist, she's a deep expert here. And her point really is computer vision is not solved yet. It's still ill-defined. When you're trying to do something like object segmentation, here's a podium. Where does the podium begin and where does it end? Does the microphone, is that part of the podium? Should those be two separate objects? It's hard for us even as humans sometimes to describe the tasks that we're trying to have the computers to do it. So it's still a hard problem, often ill-defined, and requires a lot of innate expertise, hard-fought effort to understand that and to deploy that. So she's on one end of the spectrum. Need to have that deep knowledge. Patrick is a game developer. He has knowledge about using artificial intelligence for gameplay, but also realizes that vision will be an integral part of many new games. He doesn't have any experience in doing computer vision development himself, but realizes that it's available today, wants to utilize that very much the same way as he does internet connectivity. The internet's there, I'm going to use that in my game. Vision's there, I'm going to use that in my game. And feeling like the necessary layers of abstraction and capabilities are there for him to do that effectively today. So there's one person that's a deep computer vision expert that says it's still not solved. Another person that says, well, it's solved good enough for my needs. I don't need to go deep in here, and I can use it today to deliver solutions. This brings me to a little history lesson. When I was back in graduate school, we spent lots of time working on packet switch network designs, frame relay, token ring. A lot of gory details that we've moved over the past 2 decades or so to very simple solutions like Dropbox, where I can share content, share information with anybody around the world. They don't need to know any details about how the network itself is designed, the protocols that are used to create them, and we've basically abstracted it out so anybody can use those technologies in the internet today. So what does this really imply to us? For that connectivity example, or that internet file sharing example, what were the catalysts that drove this? One is standards, and a community that adopted and drove those standards to make it happen. You can imagine a scenario if every company, every vertical company had their own versions of a network that were not interoperable with each other, we would not have the internet that we have today. So it's critical to have standards, to adopt those standards, to work together as a community here, just like this summit is, to make those forward progress on them. The next is a layered architecture. By layered architecture, I mean there's a layer of hardware, for example, in the network example I gave. Layers above it, higher levels of the software, don't really need to care about what the hardware does itself. You provide layers of abstraction, and you utilize that. So if I work at a certain layer, I only need to care about one layer up and one layer down. How do I communicate between them? Everything else is magic to me. I don't really care how it works. So that's an important part of the solution. In the network standpoint, data, a lot of it user-generated, company-generated data, drove the adoption and people wanting to do it. And then finally, with Moore's Law, increasing performance, the increasing ability to connect, store, transmit that information. I feel the exact same catalysts are happening today with computer vision, and we will have a similar explosion in terms of the ability for people to utilize it broadly. I'll go through those for the rest of the talk. So building a vision solution, what happens here? It's pretty rudimentary, but it pulls out some important questions you need to think about. The first is, from a customer standpoint, what do I want this application or solution to do? What is the actual end result that I'm trying to achieve? You then break that down into maybe an end-to-end workflow. Maybe portions of it's happening on the edge, a portion of it's happening in the fog, and other portions in the cloud. How do those interact with each other? Drilling down the next level, what's the actual workload? What's the pipeline of algorithms and kernels, and how do they relate to each other? Then looking at specifically around the visual computing pieces of processing the information, understanding it, doing analytics on it, and even rendering it, and then the hardware itself. And you can ask yourself, I only have a finite set of resources, be it time, money, people. Where do I want to spend those resources? As we saw from Mark this morning, Microsoft, with Cadence and others, designed all the way down to the hardware itself. And they said there was not something in the market that they could take off the shelf and was going to deliver their solution. So they had to do that complete stack all the way up to the software, and then letting others to build upon that. It's pretty intensive. Not every company has the resources that Microsoft has, so it's not going to be appropriate, in my mind, for everybody to have to go and deliver individual unique hardware. How can you build upon existing off-the-shelf hardware, off-the-shelf libraries, off-the-shelf programming models, and to deliver your solution? So those are the trade-offs that you need to think about as you're creating your solutions. And specifically, as I go back to my point about a stack or layered architecture, here's a generic solution for vision in particular. At the lowest level, we have hardware, and this could be DSPs, FPGAs, GPUs, general purpose CPUs. All of those can provide vision capabilities to some degree with different trade-offs in terms of programmability, performance, power efficiency, but they're available today in the market. And then typically those vendors provide low-level drivers, optimized kernel libraries, and expose those with different programming models, be it either proprietary models or standards-based solutions. And then we start to get into more complete solutions around algorithms that can be used, maybe cross-segment, something that's not just for a drone or just for retail, but something that could be generically used, and then more market-specific capabilities that are enabled with tools like lower-level tool chains around profilers, debuggers, compilers, to higher-level tools that allow for graphical user design based solutions, drag and drop based capabilities, and then obviously research that makes that happen. And the different developers have different needs in these spaces. The people that are at the low level, and this upside down pyramid, I guess, sort of tries to indicate the number of developers in each of those areas. So you typically have many fewer firmware, low-level hardware access developers, and they require the absolute most control. Low-level capabilities, they're okay often with proprietary APIs because they need to squeeze out every single ounce of performance, every single ounce of power efficiency, and to make that happen. Then you have your performance and optimization algorithm developers. They're able to use some higher level or prefer some higher level capabilities like OpenVX with our recent 1.2 release here, OpenCV for higher libraries, TensorFlow and other deep learning frameworks, and really looking for both cross-architecture, meaning hardware, as well as operating system support, and ideally standards-based solution to avoid any vendor lock-in for those. And that's really a dichotomy of those. It's not that it's OpenCL versus OpenVX versus those things. Those are different tools that are necessary to deliver a solution, and we envision the need to having those and providing those with in an overall complete solution. And that's what, from my standpoint, is required for enabling developers. It's not just a low-level capability or just a high-level capability, but a scalable solution that goes from delivering that in integrated development tool chain for doing profiling, debugging, providing rich kernel support across a variety of algorithms. And then also, as we will see here today, and I'm sure people are very familiar with this already, the vast acceleration of deep learning and other artificial intelligence capabilities marrying with classical computer vision and needing for those to be brought together in an overall solution is absolutely critical for anybody to develop solutions today. So these are some of the requirements for us to be successful as a group or community. So transition slightly here. And I think Mark brought some of these points out already, so I won't belabor them. But there's a lot of debate between, is all the processing for vision going to happen on the edge, on the client devices? Will it happen in the clouds? My answer is both. To cut to the chase, it's really it comes down to trade-offs between things like how latency sensitive is my application? Can I have an environment where I need to know immediately, like an autonomous vehicle, if this is a person, a car, something else in front of me? Or another application like the HoloLens, where I can potentially do some of that processing offline and then fill in the gaps as I learn those things. Power budget also drives this, the network bandwidth, how much information can I be sending back and forth, and then also concerns about data privacy. What do I want to keep local? Information about my camera in my home that I use for security purposes, I prefer to keep more local versus maybe some data that I have that's in an industrial setting or a smart city where that's exactly the point, is to understand what's happening in the environment. So it's really some level of equilibrium will be established here between both needing to do processing within the cloud as well as on the clients themselves. And let's see, probably my most detailed small font one, so I apologize if anybody in the back can't see this one. But the main point is around we are evolving in terms of the overall programming environments that we have today. Traditionally, we've had very classical feature-based computer vision solutions that requires the development of custom code that will run on a variety of different IP blocks or hardware. Oftentimes, low-level languages like C++, CUDA, OpenCL are used here. Then we move up to more API and library-based solutions. These are our OpenCV, Microsoft's Cognitive Services, OpenVX, and enabling those, again, with providing abstraction across the different IP and coding it once and then having it to be able to run across those effectively. And then finally, we have moved sufficiently to deep learning or DL-based algorithms and the utilization of inference engines so that they can run effectively on edge devices that have low memory constraints, that have specific floating point parameters or characteristics, and to do those in a much more effective manner than you would have, per se, from running a full training framework on those. And this would be where Caffe and TensorFlow play in here. And my personal observations and perspectives is that we are significantly moving ourselves from the left to the right here as we go up that stack, enable a broader set of developers to access this information, and causing us to explode the number of people that can deploy vision-based solutions. And some of the things that we have for our generalized examples around doing detection, recognition, and understanding of information. These are just innate capabilities that I think across many, many of those segments are happening today. And there's different trade-offs between how you would deploy each of those ones across that programming model evolution. On the feature-based custom code ones, this is actually the easiest one to do more root cause analysis when you have a failure. Why did this one sequence not detect the object that I thought it would? You're able to understand and walk through the code, do that. You also have complete control of your own implementation, so those are good things. But it does require that deep domain knowledge. It requires often a team of PhDs working on that to make it happen, and it's costly in terms of time and just the overall resources to do that. We have moved sufficiently to library-based solutions. I'm sure everyone here is very familiar with OpenCV and other libraries that are available in the market. Obviously, this provides faster time to market. It leverages the capabilities and expertise of the community. But sometimes those libraries don't exactly fit your needs. You might need to license them, and you don't have full control over what's implemented and the code within it. And if it's a black box and you have to do things like functional safety verification for different markets, this would often prohibit its usage. And finally is on the deep learning-based solutions. This is where we are now proving that these are able to surpass even human capabilities, and it further abstracts the need to even have any real knowledge about the technology or what the processing is happening in it. Send it lots of data, give it some time, and it figures it out on its own. But it's also really difficult to root cause the problem. If something happens, I don't know, this weight, if I change it by 0.01, will it actually change the result? So those are hard to root cause, especially in a very complex solution, and requires these very large data sets and long time to model. So it really comes down to the skills on the team, what you're willing to invest, and how much control you need for your solution. And I just go back to the example. I didn't know we were going to have so much discussion on Microsoft this morning. So I just use them as one example here of their cognitive services that really enables this type of capability for any web developer even. You use the URL down below, you show an image like this, and it comes back with a group of young children playing soccer or football on a field. Now, the amount of work that would be required 5 years ago for any company to do that would be astronomical. But Microsoft, Google with their Cloud Visual API, Amazon with their Go opening up of the Go capabilities as well as their recognition engine, all those things are enabling anybody to tap into that access and to make that happen today. So let's go back to Gail and Patrick and where they fit within this evolving workforce. Gail, the one that was really the computer vision expert, she worked at a multinational company or potentially an academic research place. She trades in deep algorithm expertise, understanding how vision works, and even saying that we've got a long amount of research to go before we're even going to solve all the vision problems. Patrick is really on these more emerging ones, agile development, taking in pieces that others have developed, leveraging that, putting it together into a solution, and doing that with fast time to market. My view is we're going to have both of these worlds. We're going to need a combination within the overall ecosystem and then also within companies themselves. It's not just a bunch of people that can take off-the-shelf capabilities. It's not just a bunch of PhDs that have been doing this for decades, but really marrying those two together so they can bring forward the necessary solutions and to do that with meeting the right requirements, time to market, and overall solution that meets that application intent that you decided. So where are we going in the future here? My view is that we will have a continued emergence and adoption of more of these solutions and API-based capabilities. We will have higher level language support for computer vision that allows for direct coding without necessarily going to C or OpenCL or CUDA level language. And then we will have an equilibrium between processing on the cloud, the edge, the fog, and in the data center. And what I'm asking, call to action, help needed, is really for us to continue to work together as a community to drive forward with standards-based interfaces that others can build upon and really drive that adoption and explosion of vision-based solutions. There's a lot of work, and I'd say duplication of work across the industry in data set gathering, benchmarking, algorithm development. How many face detection algorithms do we need in the world? Can we all work together to bring together the best, move forward, and tackle the next problems? And this gets back to my last point around how do we avoid reinventing the wheel, build upon each other, stand on the shoulders of giants, and deliver the solutions that are going to be fantastic for our customers in the marketplace. So thank you very much. I'm open for a few questions here.
When you're talking about bringing vision to the masses, do you see it more of a device-centric, something like the iPhone, or is it more of a subscriber base that you're looking for, like the buy-in that you gave from Dropbox? People utilizing that.
I think it's both. I think it's going to be vision on devices that people have today and making more applications that utilize vision in them, but then just many more devices having inherent vision capabilities. The point of sale terminals to drones to any device out there will have, streetlights will have them. How do those become more prevalent, and how will developers tap into those and to make solutions based on them? So I think it's a combination across those.
Gil Russell, Semiscape. I have a kind of an interesting question. One is, we're talking about a lot of application, but a limited amount of power, especially at the end of the internet for IoT. And I'm curious to your idea on how you see that going forward as far as device technology. The second question is, do you think this is going to be, the algorithms is going to go into an open source consortium?
Yeah. So in the first point on the power envelope, well, yeah, I think that's always going to be a constraint where people want to do more and more on edge devices as much as possible. And Moore's Law and other things will continue to move forward and allow us to do equal processing with lower power or lower die area, and that's part of the solution, as well as the combination across doing the right partitioning of what needs to happen on device versus in the cloud, and pushing off maybe some of the higher latency tolerant capabilities to the cloud where you don't have those same constraints. And then on the second question, in terms of an open source consortium, I think it's somewhat happens today with OpenCV and some of the other open source libraries that we have in the marketplace today. I'd like to see it go to even broader capabilities so that we are, again, adding to those and building upon each other as opposed to kind of fighting over the best algorithm. I think we need to get to a point where we decide as a community, this algorithm is good enough, it's widely applicable across, and now build on top of that as opposed to refining and getting the last 0.1% improvement over that.
I want to have everybody give them a round of applause again.